definition of a limit, and one and two-sided limits. And again, this is all still section 2.1, building the foundation for calculus.
Is this supposed to be a 4-day lesson? Like,
I spent 4 days on it last year. I made a new assignment sheet for you because it did only have 3 days on it because I had a goal at one time that I would get this out of 3 days, but it's turned into 4 days the last 3 or 4 years. So I'm okay. We got time. We only do 7 chapters in this whole year, so we're.
you just had a Christmas tree. Yeah.
Is that what you punch it to break it?
No, I punch it because it seems like there's a short, so when I hit it, it fixes it. So, and it makes me feel better. This says number 3 because this was from the other one, so I'll try to fix this as we go along. But
We have Friday after tomorrow. Yes.
we do have price time tomorrow.
Next day.
Dilly dally around. So I think this is what the problem says on your homework for 61. And again, we don't have to use the sandwich theorem on this one, but we're using it so that you can just see how it works. The good news is, for us, in this book, on my test for this, I'm never going to just give you a problem and hope you think of the sandwich theorem. On the AP test, theoretically, could that be? Yes. But I don't know that I've ever seen a problem on the AP test that you had to remember, oh, maybe I can use sandwich theorem here. But I like to make you do it because it makes you practice this whole writing and kind of using a theorem to prove that something's true. I agree when you're going to tell me in a minute, why do I need to do this? Because can't I just plug 0 in there? And that's true. I can just plug 0 in there, right? But we're going to start with this one because let's start with an easy function instead of something that has to have a ton of algebra that makes it really ugly. Okay? They're really not going to get that difficult. But this is just another way to evaluate a limit. And we talked about on Friday, the sandwich theorem says, well, what if we look at another function smaller than it and another function greater than it and sandwich that in between there and take the limit of those, and the limit in the middle will be the same. And look at this. There's no hope here that this is going to work, but I'm just going to try this. Maybe this will work. So step 1 is these are usually always trig functions because otherwise we can't sandwich it in between 2 things. Can you tell me what sign, forget about the x for a minute, what sign is stuck in between on the graph? Like on the y values, what's the biggest sign ever gets and what's the smallest sign ever gets? Negative 1 and 1. So if it was just sine of x, you agree that I could say sine of x I'm just going to sit over here. I'll get more accomplished. I could say that sine of x has to be less than or equal to 1 and greater than or equal to negative 1. Which is why you'll see, I think on every sandwich theorem problem that we do, they give us a trig function because we can talk about the domain of that trig function. But this is not what this function is, but I've kind of made an inequality now. So if I want this to become this, could I just multiply all of this by x? So when you do the sandwich theorem, step 1 is find basically what is the range of that function. Usually it's negative 1 to 1, because usually it's sine of cosine. Then make this match this. So to do that, I'm going to multiply everything by x. And I now have negative x is less than or equal to x sine of x, which is less than or equal to x. Now the sandwich theorem says, if you can tell me the limit of this function, the left, and the limit to the function on the right of it, or above it, if those limits are the same, then the limit in the middle has to be the same. Works out really great when you have something that doesn't work with substitution, that doesn't work with the special limit, that you don't have a graphing calculator for, and you don't know what the graph looks like. That's why we do the sandwich theorem. What I want you to practice is just working it out. So I'm going to say, let's take the limit of each side. So let's take the limit as x approaches 0 of negative x. Let's see what that equals. And let's take the limit as x approaches 0 of the function that's bigger than that. Ignore the giant line in the middle of that. And the idea is, even though x sine of x is a pretty easy function, the ones on the outside should be even easier to simplify. If I put 0 in there, do you agree I'm just going to get 0? And if I put 0 in here, do you agree I'm just going to get 0? Let's say this was divided by x here, right? Then we couldn't plug 0 in the middle, and that's where the sandwich theorem might be useful. It says, use the sandwich theorem to confirm your answer. I want you to kind of use the conclusion of that theorem to write your answer. The theorem says, if this equals a number, and this side equals the same number, then the one that's sandwiched in between has to also equal the same number. And I want you writing some words there, okay? You don't have to write up a paragraph, but I'm going to say, oh my gosh, what even happened? I'm just going to type
So,
this.
if those two limits ended up being two different actual numbers, then you would just take the closest middle? Or
Then we couldn't use the sandwich theorem. They have to equal the same thing.
Okay.
Okay, so I'm going to say, since the limit, and pretend I have x approaches 0 underneath there, of negative x equals the limit as x approaches 0 of x, which equals 0, right? So since the left side limit equals the right side limit, and they both equal the same number, do you agree that that's what that says right there? You could write it out much longer. I just try to make it as short as possible. Oh my gosh, this won't even work. Then the limit as x approaches 0 of x sine of x also equals 0 by the sandwich theorem. Or because the sandwich theorem says this, then that's what it should also be. By just saying that one sentence, that's like proving it. People hate that word proof. But if you can use a theorem and say that the if part is true, then you can say the then part is true because the theorem says so. And this should really say as x approaches 0 under all of these. You don't have to say it that exact way every time, but you have to tell me that the left and the right side equal the same number, so then that means the one in the middle also equals the same number. Here's the great thing. They tell you, like on 61, says use the sandwich theorem. It might even say what this one said, which was look at the graph. Like we could look at the graph and show that it also equals 0. But on your test for this chapter, I'm going to give you a problem like this and ask you to show me by the sandwich theorem that it's true, where you have to show me and then you have to write that out. And that's kind of the whole thing on the free response of the AP test, that they make you write some stuff out. Maybe quote some theorems every now and again. Okay, so this is like theorem number 1 in techniques. So you can do 61 now, just like this. Make it match up. Left and right side should be pretty easy. It's usually like 0 or 1. And then, okay. And the great thing for us, it always works. Like Colin said, what happens if they don't equal the same thing? Well, you could use the sandwich theorem, so they're not going to give you a problem that doesn't work. Does that make sense? Okay. This is ridiculous. Oh, look at that. I got this from an email and it made me laugh because it said someone in their class said, when am I ever going to use the sandwich theorem? And this made me laugh because it said it was a real life application, that if a slice of bologna is sandwiched between the bottom piece of bread and the top piece of bread, and both the top and bottom slice are going to your mouth, then the bologna is going to your mouth also, which I thought was just silly. Okay. I'm the only one that thinks that's funny. So that's what the sandwich theory is saying. If the top function and the bottom function are both approaching the same thing, that the one that's in between it would also approach the same thing. You know, write that down. Okay, here we go. Left and right hand limits is another way to evaluate limits, and it's another notation. So this is kind of hard to see, and I'm sure it's not going to show up when I I write it, but instead of saying just the limit as x approaches c, it says the limit as x approaches c with a little plus sign. And that means the limit as of f as x approaches c coming in from the right side, so positive side. And then if I only want to look at the limit coming in from the left side, that would be the limit as x approaches c, and they put a little negative sign there. So you got to make sure that you can read that when you're writing things out on your paper. And so I think maybe I have a. Oh yeah, okay. There's just a lot right in here, but. This is the definition of a limit, so I'll kind of let you write this and then I'll talk because I know it's hard to listen and write at the same time.
Is it supposed to be limit plus f, that's like a positive function?
Right here, this plus,
No, yeah, why get this up there?
it's just with the c, right? It's not plus f of x. It's the limit as x approaches c. The c has the plus sign next to it because it means, the plus sign means coming from, and then the f of x is still up here. And then
Oh, so
the,
as your values get smaller to the right of the function, so like if it was 1, that would be like 1.01
yes,
on that side.
and coming from the left would be like 0.9, 0.99, and we're going to look at a graph in a minute, and it'll make more sense with it. The last couple of years on the AP test, there has been one part of a free response that asks you a question and they want you writing out this definition of a limit. We get kind of lazy sometimes when we do this because we're like, oh yeah, the left and the right are the same. But if they ever ask you to prove or justify that a limit exists, you have to prove that the limit coming from the right is equal to the limit coming from the left, which is equal to the limit itself. A little math lingo. In geometry, you learned all about if and only if, right? It's been a while, but like if this, then that. You can switch it around. Well, if and only if means it's true, like you could read it both ways. Like both ways could be the if. This is the symbol for if and only if. If you don't think you're going to remember that, you could just write if and only if in between there. But that's what those, an arrow with a point at each end means if and only if. So this is definition of a limit. So hopefully up to this point you kind of feel like a limit is what happens on the y-axis as the x gets closer and closer. The important part that we haven't said until today is it has to be reaching the same thing from both sides, and that's the whole right and left hand side. So this is saying that the limit as x approaches c of a function equals some L value if and only if the limit coming from the right equals the same thing as the limit coming from the left. So you have to check, if you're making a table and you're finding the limit as x approaches 1, you would have to check 0.9, 0.99, 0.999, and you'd also have to check 1.1, 1.01, 1.001. You have to check from both sides. Graphically, it's super easy because you can kind of just think about following the graph coming from both sides and making sure that they equal each other. No, you're good. I just like to make sure that I didn't look for moving pencils so far. I see I'm not moving it from this way. Probably because I yelled too much at Mason, punched the board too much, and talked about culture. Those could be the 3 reasons why we don't make it. No, it started getting like this last year, and it's just becoming worse. Like, I'm really going to talk to them today and tell them they need to come to my room and see how terrible it is, because it cannot wait.
It'll probably
Whenever they show up, it won't work. Or it won't.
Miss Sol, 6th hour, it never works. Usually I'm pretty good, like This is very similar to what's on your homework today. They're gonna give you a graph, they're gonna ask you to find a bunch of limits. Again, just like what we did before, there's not a whole lot of stuff to compute. It's a questions asking you, do you understand what we're doing here? And so, if you're gonna make this, make sure you know that this comes up, like, this is up at 4 when x is 2, that's an open circle. This at 3 doesn't show, but that means that would be a closed circle. This would be a closed circle here at 0. This seems to stop, so I'm going to make a closed circle here. Doesn't have to be perfect, but we are looking for y values here, so you want to make sure that they at least start and stop where they're supposed to, because otherwise it's going to be hard to see. In your book, it's really easy to see where they start and stop. So. Really only have this one and one more example, so there's hope we're gonna make it. And if not, we'll spend it. That's a nice thing of spending a whole year doing this class, as opposed to one semester. But pay close attention today of what's next to those numbers, whether it's a plus sign or a minus sign. That means coming from the right side or coming from the left side when you're doing this. Are we still writing? Okay, I'll be quiet. So if you aren't done writing all A through E, you can just write A, like you can write each one as we go, so you don't have to feel like you have to have it all written ahead of time. I'm not gonna go back with it. But if we look at A, find the limit as x approaches 0 coming from the right. That means I don't care what's happening coming from the left. I only want to know as x gets closer and closer to 0, coming in from the right-hand side, what is the y value approaching? As x approaches 0, like if I picked 2, that would be 4, right? If I picked 1, it looks to me like that's at 1. If I'm getting closer and closer to 0, what is the y value? 0.
So it doesn't, it's not like 3, what does the 3 have to do with?
The 3 is just a whole different part of the graph. If I'm just getting close to 0, is 3 close to 0? So I don't care about this part. Does that make sense? Like if I was making a chart, I would only be picking close numbers to 0, like 0.1, 0.01. What about 2? What's happening as x approaches 2 coming from the right? Maybe we should skip that one for a minute. But coming from the right, do you agree that that's this side? So coming from the right, am I talking about this segment at all? No, I'm talking about over here. If I start way out here and get closer and closer to 2, we're cruising along here. But am I ever getting super close to 2? Do you agree that it stops here when x is 3? So what do you think I'm going to write there for my limit? Yeah, it does not exist because I can't pick numbers like 2.1, 2.2. It stops. So I'm going to say does not exist, or no limit, or undefined. No limit exists. I don't know how I wrote it.
I am very confused though, because like 0 wasn't on that first line that we passed by. We came on the right that time though, too.
But that was getting close to 0, right? Like, you got to think to the right of 0 is what this means. To the right of 0, here's 0, to the right of 0 is like this little segment. You're right. We could go way out here. We could make a chart here, and we could say when x is 3, y is 0. When x is 2, y is 4. When x is 1, y looks like it's at 1. I'm going to just pick numbers here and say when x is 1/2, I wanna know what happens as I get closer and closer to 0. Does that make sense? And to the right of it just means directly to the right of it. Not way out here. I wanna go just on this side of it as opposed to on this side of it. Does that make sense?
So it's to the right of the point.
To the right of C that you're approaching.
Okay.
Okay? So on this one, if I'm approaching 2 from the left, find 2. To the left of 2 is going to be over here. So find where that graph is. So that would be this segment of the graph. You with me on that? And if I like to think about going up the line. If I get closer and closer to 2 coming in from the left side of 2, right? What is the y value that I'm approaching? 4.
Does that matter if there's a limit?
It does not matter. Because remember, limit is what is it getting close to, not what is the actual value. The actual value doesn't have to exist. No, it doesn't matter. It's not recognizing that I'm holding a pen right now is the problem. I know, but it's stupid. See, look, the lights are out, this turns red, then it restarts, and then it's stupid. So, it's okay, we can continue here. Now, look about this one. It says, what is the limit as x approaches 2? This is what you've been doing up until this point. That means, what is the limit itself? So now we know that means coming from the right and coming from the left, those have to be the same. So if we've already looked at these, we can look at the graph also. If these are not the same, is this limit going to exist? No. Definition of a limit. The left and the right have to be the exact same number in order for the limit to exist. So the answer here is, does the limit exist at 2? And you can look at the graph and say it doesn't because it's not approaching the same value. If you were coming in from the left and the right, they're not even the same. So no limit exists on part D. Bad news for the people at home watching this because I was writing nothing on the board and just pointing at things. See, this is what it says, and I tell them this. It says the USB, what connects my smartboard to my computer so that it recognizes things, says it does not work. Send this video to the technology people. Say, watch this. So what about E? Don't yell it out, but think about it for a minute. If I want to know the limit as x approaches 3 from the right, that means go to the right of 3 or go bigger than 3 and see if you were getting closer and closer, what's happening to the y value there as x is approaching 3. I would say 0, because as I get closer and closer, well, we thought about it. See if anybody had an answer, but we should have clickers. And the clickers. I have them. I don't use them. We don't have time right now. We can't even get the stupid smartboard to work. Does that kind of make the left and right thing a
So
little bit?
pretty much, we're just kind of taking random points and then.
Not random points. We're looking closer and closer to whatever final limit. Strategic place. All right. This is a piecewise function, so write that out.
Yeah, this really sucks for all the people that skip school.
Yes, so much for these skippers. We're gonna feel really bad if something's really bad and why they're not here. We should've.
I know people say that when I'm going.
Because we know you skip as many days as possible.
Sometimes we still don't.
If you really were, if something really bad happened, I would feel terrible wasted because I always think you just skip. Happens to be on days projects or good work, big test. So just a coincidence. So this is 3 minus x when x is less than 2, 2 when x equals 2, and x over 2 when x is greater than 2. This c equals 2, this is the way the homework is written, so I wanted you to give you one the same way. And we're going to graph this, okay? So I have these directions here, but ignore that for a second. Part A says draw the graph of f, and so I don't know that you really need to write that down, but we're going to draw this graph if you haven't already done so or working on it. And again, although you have a graphing calculator, there are going to be times, like with a piecewise function, I would expect that you could sketch the graph of a piecewise linear function or even a simple quadratic pretty easily. something like that. And then at x equals 2, it's just going to be a dot, right? Because normally that's a line, but it's only at x equals 2. It's going to be like this, like a dot. What's wrong, Zane?
I was taking the middle line as 2. I was
Okay.
confused of where you were.
Then when x is greater than 2, it's 1/2 x. Which means you could start over here, or you could just pick points. Like if you plug 3 in there, you're going to get, oh no, we should plug 2 in there first. If I plug 2 in there, I get 1, so that's also going to be right there. And then I could just go up 1 over 2, up 1 over 2. And I think it's going to kind of look like this little V shape with a dot right above it. So part B, I wrote this up here because part B says determine the limit as x approaches c from the right and the limit as x approaches c from the left. So that's where the c value comes into play because in the homework the directions are the same for all the problems. So you could just put for part B, find the limit as x approaches 2 from the right and find the limit as x approaches 2 from the left. Oh look, I already have the answer here. What? Well, when I save my notes, it always asks me if I want to save them to what's been written on, and I always say yes. And so then before I teach it again, I go through and kind of look at the notes and see what I want to change, see what I want to leave. So again, coming in from the right, coming in from the left, of 2, all right? So at 2, coming in from the right would be on this side, yes? This would be to the right of 2. And again, you're just asking yourself, there's not really any work to show, what's happening as I get closer and closer to 2? And the answer is the y value is 1. Approaching 1. It's not exactly 1 because it's an open circle there, right? But we could keep getting closer and closer to 1. And the same thing if I come in from 2 from the left, coming in this way, it's also approaching 1. The function doesn't actually equal 1 there, though, right? Because it's a piecewise, it actually equals 2. That has nothing to do with the limit value, but we could say that. The third...
So would that be the limit of the
Part C asks you, does the limit exist? And since you did part B, you should be able to say whether or not it exists. And Philip, what were you about to say?
I was just gonna ask, like, if it does approach 1, then why does it keep pushing?
Well, because it's the function value's 2, but the limit is 1. And so the next part of this, we're still in section 1 of this chapter, but later in this chapter, we're going to talk about being continuous or not. Would this function be continuous? No, because there is that hole there that moves up. But it does have a limit, and so we're going to talk about that even if it's not continuous, it could have a limit. Sometimes it's not continuous, it doesn't have a limit, but to have a limit, this dot up here means nothing in terms of having a limit. So does this limit exist? The answer is yes. If so, what is it? 1. And it says if not explain. You could explain even if it was, but it doesn't say you have to. But if not, you need to say the left-hand side, the left-hand limit doesn't equal the right-hand limit. And that would be your explanation, because that's how you prove if a limit does not exist. Okay, so a lot of your homework today is looking at pictures that are already graphed and just saying what the left and right-hand limit is or if a limit exists, and then there's 1 or 2 of these. And then 61 I put on this assignment, which is the sandwich theorem. So I put that on this assignment. If you have it numbered on your other paper, you can put it on your other paper. And we'll talk about this tomorrow and